Intro to LLM systems. Hello, everyone. Today I'd like to walk through how to think about LLM systems in system design. An LLM system is not just calling a model. The model is only one component. A real LLM system is an application architecture around the model. It provides context, retrieves knowledge, calls tools, validates outputs, enforces safety, monitors quality, and controls latency and cost. A typical flow looks like this. User input goes into a prompt builder, then the system retrieves context. Then the request goes to the LLM. The LLM may call tools, the response is parsed, safety checks are applied. Finally, the system returns the final answer. Now let's start with the core framework. When I think about LLM systems, I usually break them down into 5 parts. First, model, prompt, and context. Second, RAG and embeddings. Third, tool calling and agents. Fourth, memory and personalization. And finally, evaluation, observability, safety, latency, and cost. The main trade-off is quality versus latency versus cost versus safety. A more powerful model and more context may improve quality, but they also increase latency and cost. Let's start with the foundation: model, prompt, and context. The model is responsible for understanding user input, reasoning over context, following instructions, and generating text or structured output. But the model alone is not enough. The prompt defines the task, role, instructions, output format, constraints, and examples. For example, a good prompt should tell the model what to do, what information it can use, what format to return, what to avoid, and how to handle uncertainty. Context is the information given to the model at runtime. It can include the user question, conversation history, retrieved documents, tool results, user profile, and system instructions. But there is a limit: the context window. The model cannot see unlimited information in one request, so the system must decide what context is most relevant, retrieve it, rank it, truncate it, or summarize it. The key idea is this: prompt controls behavior. Context controls knowledge. Next is RAG. RAG means Retrieval Augmented Generation. The flow is simple. First, retrieve relevant knowledge. Second, add it to the prompt. Third, let the LLM generate an answer. Why do we need RAG? Because LLMs may not know private company data, recent information, domain-specific documents, or user-specific content. Instead of relying only on model memory, the system retrieves relevant documents at runtime and provides them as context. This improves factuality and allows the model to answer using external or updated knowledge. Embeddings make this possible. An embedding converts text into a vector. For example, the phrase refund policy can be converted into a list of numbers. Similar meanings have similar vectors, so the system can use vector search to find relevant document chunks. The key idea is this: RAG grounds the model in external knowledge. Embeddings make semantic search possible. Now let's move from knowledge to action. LLMs cannot reliably do everything internally. They cannot directly query a database, search logs, calculate precisely, send emails, call payment APIs, or execute internal workflows. That is why we need tool calling. A tool flow usually works like this. The user asks a question, the LLM decides that a tool is needed, the system validates permission, the tool executes, the tool result returns. Then, the LLM uses the result to answer. The key point is that the model should not directly execute the tool. The application executes the tool safely, with permission checks, argument validation, logging, and guardrails. Agents go one step further. An agent is an LLM system that can plan steps, use tools, observe results, decide the next action, and iterate until the task is done. The loop looks like this: start with a goal, create a plan, call a tool, observe the result, decide the next step, then produce the final answer. The key idea is this: tool calling gives the LLM access to external systems. Agents allow multi-step execution. LLM systems also need memory. Short-term memory comes from conversation history. Long-term memory stores persistent user preferences or domain information. Working memory stores temporary state during task execution. Memory helps personalization, but it also creates privacy, freshness, and accuracy risks. Production systems also need output validation. LLMs can produce invalid JSON, wrong formats, hallucinated facts, unsafe content, or unsupported actions. So the system should validate structure, check business rules, verify tool results, attach citations when needed, and retry or fallback if output is invalid. Evaluation is also critical. Offline evaluation tests prompts and models before launch. Online evaluation monitors real user outcomes, task completion, latency, cost, safety, and user satisfaction. The key idea is this: production LLM systems should not blindly trust model output. They need validation and continuous evaluation. Safety is a core part of LLM system design. Common risks include hallucination, prompt injection, data leakage, unsafe tool calls, unauthorized actions, toxic content, and overconfident answers. Guardrails include input filtering, output filtering, tool permission checks, retrieval source validation, PII redaction, human approval for risky actions, refusal policies, and audit logs. Observability is also important. We should log prompt version, model version, retrieved documents, tool calls, latency, token usage, cost, validation errors, safety flags, and user feedback. Cost and latency must also be managed. Large models, long prompts, more tool calls, more retrieval, and multi-step agents all increase cost and latency. A good system routes simple tasks to cheaper models and reserves expensive reasoning models for harder tasks. To summarize, an LLM system is not just a model. The model provides language and reasoning. Prompt controls behavior. Context provides runtime knowledge. RAG grounds answers in external data. Tool calling connects the model to real systems. Agents support multi-step tasks. Memory enables personalization. Validation, evaluation, observability, and safety make the system production ready. The final insight is this: LLM system design is not about calling a model. It is about building a controllable, reliable, safe, and measurable application system around the model. Thank you.